is anterior rami. Now we want to look at the second aspect of development of respiratory system, which is the maturation of lungs. If you don't forget, in my previous video I talked about the introductory aspect, where we talked about development of the tracheoesophageal septum that divides the trachea anteriorly and the foregut which we divide to the esophagus posteriorly. So we have something like this as the anterior view. So this is our foregut. Then coming up from the foregut is our endoderm, which is the lung bud. So this is here. Now this is our foregut, and this is our lung bud. So this lung bud is also regarded as the respiratory diverticulum. Now there's something I want you to know, that during the maturation of lungs, do you get, the maturation of lungs begin at the inferior aspect of the respiratory diverticulum, which is the lung bud. You know, later on, this will be the foregut, and there will be loss of communication between the foregut and the lung bud, whereby it is going to form what we call the It's going to form the lung bud. Now, this is our foregut, and this is our lung bud. So this lung bud, at the caudal part of the lung bud, guys, that there is a kind of dilation. There is also something that bud off from the lung bud. This is what we call the bronchial bud. So it is from the bronchial bud that is when the maturation of lungs occur. That is when the lungs begin to develop. So in the maturation of lung, there are 4 stages involved. The first stage is what we call pseudoglandular stage. Yes, pseudoglandular stage, which occurs from week 5 to week 16. Yes, week 5 to 16, though it varies. Number 2 is the canalicular stage. Canalicular stage, which is week 16 to 26. It varies as well. Then number 3 is the circular stage. Yes, also called the terminal sac stage, which occur around week 26 to birth. Yes. Then the last one is the alveolar stage. Alveolar stage, which occur from birth to 8 years of age. That is the stages involved in the maturation of lung. So let's start with the first one, which is the pseudoglandular stage. Now at the pseudoglandular stage, yes, pseudoglandular. Now at the pseudoglandular stage, what happens? Coming up from the bronchial bud, do you get what I'm saying now? Now this is the trachea. Now coming up from the trachea is the bronchial bud. So at the pseudoglandular stage, the bronchial bud bifurcates into 2. So this bifurcation is what we call the right primary bronchi. While this one be the left primary bronchi. Yes. So we have the right primary bronchi. Is that you call it primary, or you call it principal bronchi, or you call it main bronchi? So we have the right primary bronchi and the left primary bronchi at the pseudoglandular stage. Then during the process of pseudoglandular stage, those structures also bud off. Some structure also bud off again to give rise to another structure. So in development of lungs, structure are budding off from another structures. That is what development of lungs is all about. So another structure bud off from the bronchi. At the right, about 3 structure bud off, because you know in the right lung we have 3 lobes, while in the left lung we have 2 lobes. So at the right, a structure bud off 1, 2, and 3, while at the left 1 and 2. This structure that bud off is what we call the what? This here is the right secondary bronchi. While here is the what? Left secondary bronchi. Is that you call it secondary, or you call it what? Lobar. Yes, you can also call it lobar. Is that you call it secondary, or you call it lobar bronchi? Then as time goes on, during subsequent development, another structure also bud off from the what? Secondary bronchi. Can you see? It's just budding off, giving rise to structure and so on. So another structure bud off from here, it bud off. Here it also bud off. Here it also what? Bud off. Here as well, structure bud off. It bud off. Yes. So this structure that bud off at the right side, that's what we call the what? Right tertiary bronchi. While here is what we call the what? Left tertiary bronchi. You know, the right tertiary bronchi is about 20 of them, while this one is about 18. Yeah, this one is about 20, while this one is about 18 of them. So the last thing that occurs in the pseudogland last thing is that from this right and left tertiary bronchi, is it that you call it tertiary bronchi or you call it segmental bronchi? Yes, you can also call it segmental bronchi. Yes, so you can call it left segmental bronchi and right segmental bronchi. So the last thing that occurs at the pseudogland last thing is that from this segmental bronchi or tertiary bronchi, another structure develops. Yes, they also bud off. They also bud off. Can you see? They are budding off from the what? Tertiary bronchi. Those structures that bud off are what we call the terminal bronchioles. Yes, the terminal what? Bronchioles for both the right and the left part. We also have here to the what? Terminal bronchioles. So that is the end of pseudoglandular stage. So at the pseudoglandular stage, we start from the primary bronchi up to the formation of the terminal what? Bronchioles. So that is all about that. The next stage is the what? Canalicular stage. Yes. So the canalicular stage. Canalicular stage. Now at the canalicular stage, let's take a portion of these bronchioles, which we call terminal bronchioles. Now, let's say this is the what? Terminal bronchioles. Yes. The terminal bronchioles. Now from the canalicular stage, another structure bud off again from canalicular stage, which goes like this. This structure that bud off is what we call the what? Respiratory bronchioles. Yeah. Then from the respiratory bronchioles, another structure bud off, which we call the structure is like this. Bud off. This structure that bud off is what we call the what? Alveolar duct or sac. Yes. Then later on, we now have the formation of what we call our what? Primitive what? Alveoli. These are primitive alveoli. Yes. These are primitive alveoli. Yeah, so these are what? Primitive what? Alveoli. And the last thing that develops in the canalicular stage is the what? Pulmonary capillaries that is going to feed the alveoli with what? With blood. Yes, pulmonary capillaries also form pulmonary capillaries. Yeah, so there's something I want you to know about this primitive alveoli at the canalicular stage. This primitive alveoli that you are looking at the canalicular stage is something like this. They are like this. Let's say this is the primitive alveoli. It's something like this. Yes. Now, as you are looking at this primitive alveoli, let me make the diagram very clear. So we want to zoom this primitive alveoli and look at it in details. Now, one thing I want you to know about this primitive alveoli at the canalicular stage is that the primitive alveoli at this stage is immature and it cannot facilitate gaseous exchange. Do you understand what I'm saying? Why? Because the cells that is present here are all cuboidal cells. So the experience of cell here, the cells are all what? Cuboidal cells. Do you get it now? And this cuboidal cell cannot facilitate gaseous exchange. Oxygen and carbon dioxide cannot diffuse through these what? Cuboidal cells. That is why these alveoli are still what? Immature. That's why we call it primitive alveoli, because the cuboidal cell cannot facilitate gaseous exchange. And the alveoli we need must ensure gaseous exchange, because that is the main reason of alveoli. That's why we call it an ESA, so that it can facilitate gaseous exchange. But now right here, the alveoli is still immature. Do you understand what I'm saying? So that's what occur at the canalicular stage. So at the canalicular stage, gaseous exchange does not occur. Diffusion of gases does not occur here. And it is at the canalicular stage we have the terminal bronchioles becoming the what? Primitive alveoli. Then we also have the pulmonary what? Capillaries. Yes, these are the what? Pulmonary capillaries. That is going to feed blood into the what? Primitive alveoli. Now the next stage is what we call the circular stage. Yes, the circular stage. Also called the what? The terminal sac stage. Now when we talk about the circular stage, at the circular stage, there is just like the canalicular stage, but just that something, there's something that differentiates this stage from this stage, but it's kind of the same. Now at the circular stage, there is an increased formation of what? Respiratory bronchioles. Yes, there is an increased formation of what? Respiratory bronchioles at the circular stage. Also at the circular stage, there is an increase in alveoli. Yes, the alveoli become increased and it become more mature. And also there is presence of increase in pulmonary capillaries. Yes, that's what you need to know about this stage. And at this stage, there is formation of what? Basement membrane. Basement membrane. You get? Where the what is it called? This alveoli will rest on. That's what called the basement membrane. Now there is a significant difference between the canalicular stage and circular stage. What is that difference? If you don't forget, at the circular stage, the primitive alveoli are immature. Why? Because they are made up of cuboidal cells. Now at the circular stage, we notice that the alveoli become something like this. Now the cells are made of the alveoli. Yes, there's something I want to do out from here. Now, you will notice that before, during the canalicular stage, all the cells that make up this what? Primitive alveoli are all cuboidal. Now, at the circular stage, what happens? Most of these cuboidal cells has regressed and converted into what we call squamous cell, flattened cell, because it is squamous cell that can allow gaseous exchange. It's squamous cell, flattened cell that can allow diffusion of gas. Oxygen can pass through here, and carbon dioxide can also pass through. Those are the kind of cells we want. So at the circular stage, most of the cuboidal cell has regresses. Do you get what I'm saying? And they are converted to become squamous cell, which are flattened cell that can enhance or facilitate gaseous exchange or diffusion of gases. So these cells that are flattened cells are what we call type 1 pneumocytes. And there are about 90% of them that make up the what? Alveoli. While the second one is the what? Type 2 pneumocytes. And this type 2 pneumocyte is about 10%. Before they are much pretty available here. But as time goes on during the circular stage, they regress and are replaced by squamous cell, which is type 1 pneumocyte. So this type 1 pneumocyte enhances gaseous exchange. It facilitates diffusion. But the type 2 pneumocyte is not responsible for gaseous exchange, but it performs a particular function. What is that function? The type 2 pneumocyte secretes a layer of lipid film and protein, which we call surfactant. Do you get what I'm saying? The surfactant reduces the surface tension of this what? Alveoli. So that during lung inflammation, the alveoli can pop up and be filled with air. And during expiration, it prevents alveolar damage. That is the function of the surfactant. Do you get? So it reduces surface tension in the alveoli, preventing lung or alveolar damage. That's what you need to know about what? Surfactant. Now the last stage is the what? Alveolar stage. Yes. So at the alveolar stage, what you just need to know is that there's also increase in alveoli. There's also increase in pulmonary capillaries. There's also present in basement membrane. But the only difference between the circular stage and the alveolar stage is that the alveoli become more and more mature and it can enhance, and the alveoli become efficient in gaseous exchange. Why? Because before we have the alveoli to be like this, which we have the squamous cell type 1 and the cuboidal cell type 2. Yes. Now later on during the alveolar stage, a septal will be formed within the what? Alveolar. And this septal will also contain cells that are squamous and cuboidal. So can you see squamous, cuboidal, squamous, cuboidal, squamous, cuboidal, squamous, cuboidal. Do you get it now? So this septal increase the surface area of the alveolar to ensure more and more gaseous exchange. Do you get what I'm saying? It increases the surface area of the alveolar so that more gaseous exchange can occur. That's the essence of the alveolar stage. And you need to know that at birth, our alveolar is about 100 million. But when we reach 8 years, the alveolar begins to increase to about 300 million. Now, there's something I want to say before I end this video. There is something that occurs before birth. Do you get it now? Before birth, there's something we call fetal breathing. Fetal breathing occurs around the circular stage, whereby the developing fetus begin to breathe in amniotic fluid. Now, when they breathe in amniotic fluid, the amniotic fluid is present within the what? Alveolar. The essence of the breathing mechanism of the fetus is that the amniotic fluid enables the lungs and muscles to work together. Do you get? The amniotic fluid prevent the collapse of this alveolar before it starts functioning, before the alveolar starts become filled with air. Do you get what I'm saying? So that's the function of the what? Amniotic fluid at first. Do you understand my point now? So during before birth, when the baby is not born, we are breathing in amniotic fluid so that it can keep the respiratory muscles intact. Do you get what I'm saying? That's the essence of that. Then after birth, what happens? When there's first cry of the baby and the baby cry, yeah, what happens? There's rapid intake of air. Do you get what I'm saying? So when the air reaches this primitive alveolar, what happens to the what? Amniotic fluid? The amniotic fluid becomes sucked up in the what? Pulmonary capillaries, leaving a layer of film behind, which we call what? Surfactant. So the presence of surfactant. You know, before we are breathing in amniotic fluid. Doing that is what occurs before birth. Then at birth, when the baby cries and there is rapid intake of air, the air will clear away the what? Amniotic fluid, so that the amniotic fluid got absorbed in the what? Pulmonary capillaries. So when the amniotic fluid got absorbed, the only coating layer of fluid that is present in the alveolar is the surfactant. Do you get? So as you are inhaling air, as the squamous cell is allowing gaseous exchange, what happens to the type 2? They secrete surfactant. Do you get what I'm saying now? Because the surfactant is needed for lung inspiration and expiration as well. So that is all about development of the respiratory system. Now, the clinical correlate is the infant respiratory distress syndrome. We call it what? Infant respiratory distress syndrome. Yeah, this is a condition whereby a baby is born prior to the development of type 2 pneumocytes. Do you get? We call them premature baby. Do you get? When the baby is born before the development of type 2 pneumocyte. If a baby is born before the development of type 2, what happens? That means there will be no production of surfactant. And you know, I've told you that the major reason why we have surfactant is that it coats the primitive alveoli, it coats the alveoli, so that when there is inflation of air, it will pop up and allow the lungs to be what? Inflated. And during expiration of air, it prevents alveolar damage. That's the function of surfactant. But when there is no surfactant, what happens? The alveoli can become damaged. Do you understand what I'm saying now? That is the reason of surfactant. And the surfactant is also responsible for immune responses. And any pathogens around the alveoli, the surfactant also render them useless. That's the function of surfactant. So when a baby is born prior to development of type 2 pneumocytes that secrete surfactant, that condition is called infant respiratory distress syndrome. So that is all about this video. Please, at the end of this video, there will always be a practice question. Please practice it well so you can enhance your understanding on what maturation of lungs is all about, from the pseudoglandular stage up to the alveolar stage. Thanks, and its anterior rami.